So this lesson is about solving equations that are exponential equations, and to make something an exponential equation, basically there needs to be a variable in the exponent. So if I have something like this has an exponent, but it's a number, a 2, whereas down here on these equations, we see that the exponent is an x, so the ones today are exponential equations. Above here, this would be considered a quadratic equation. So we're going to learn a special technique for certain types of exponential equations called the method of common bases. So this really ties in with those powers that you need to know, the chart we've introduced. And basically you look at the two bases, 2 and 16, the two numbers on each side, and you try to make them have a common base. So I know I can write 16 as a power of 2. 16 is equal to 2 to the 4th. I'm going to leave this side because that already has a base of 2. Once I have the bases the same, we're saying 2 to the x equals 2 to the 4th, so I can actually cross off those bases and just say that x equals 4. So we'll look at a couple more. The next one, we have 3 to the x equals 27. So now the common base is 3 because I can write 27 as a power of 3. So 27 is equal to 3 to the 3rd. Then I can cross off the 3's, and I just get x equals 3. So looking at the next one, I have a fraction, which means I'm going to have some sort of negative exponent if I notice that I can do common bases. So I know that 25 is equal to 5 squared. So 1 over 25 is equal to 5 to the negative 2 power. The other side can stay, and we'll have some where we have to change both of them soon. So here, 5's are the same, so x equals negative 2 in this case. So now we're going to look at some, and I'm actually going to show you 2 different ways that we can do the next one. 16 is a power of 4. Now, 4 over here doesn't have anything on it, so I can write that side as just 4 to the 1st. Over here, I'm going to take the 16 and write it as 4 squared. And then I have that little x, so I'm going to write that next to it. So basically the 16 changed into 4 squared, and then the x stayed there. So from here, we can cross out those 4's. 2 to the x equals 1. Divide by 2 to solve, so x is 1/2. And that should make sense because if I look back at my original problem, 16 to the 1/2 is equal to 4. And with some of these easy ones we're starting out with, you can kind of figure them out in your head. Now, 3,125 is not a power of 5 that I know. So basically, I do know, this is the type of problem we're going to see. So I'm getting out a calculator. I wish I had one already that I could show you, but basically I'm just going to try stuff. So I'm going to try 5 to the 4th, but that's 625, and I do know that one. If I type 5 to the 5th in my calculator, 5 to the 5th equals 3,125. So I can write this side as 5 to the 5th, and this side is a 5. And the way the number looks, ends in a 25 plus the other side already has a 5, made me think that I would start checking powers of 5. So this one, we get x equals 5. The last one, also not something I made you guys memorize. So 9, 243 is a power of 9. So in my calculator, if I try 9 to the 3rd, actually, no, it's not. 243 is not a power of 9. So basically here, we're going to start to head into those more difficult problems. Now we have to think, well, what else could I do with a 9? So a 9 I could write as 3 squared, okay? Now checking the 243, the highest I made you guys memorize, or we made you memorize, was 3 to the 4th is 81. On my calculator, I'm going to try 3 to the 5th. So I'm typing that in, and that is 243. So in my calculator, and you just start, trying different powers of 3, that's 243. Within reason, you can get an idea of what numbers you should be checking. So this 243, I can rewrite as 3 to the 5th. And I'm going to rewrite the x. So this is the first example where I had to change both of the numbers to a smaller number to create that common base. And that's pretty typical that you'll have to change both of them as you get into more difficult problems. So I'm going to cross these out. I get 5 to the x equals 2. So x equals 2/5 on this problem. Now, looking back over at D, I just want to show this quickly. I could have done that with D because 16 and 4 are also both powers of 2. So if I wrote 16 as 2 to the 4th and 4 as 2 squared, that also would have worked because 16 and 4 are powers of 2. They're also powers of 4, which is what I used the first time. And if I solved this equation, right, divide by 4, I would get the same answer as 1/2. So sometimes isolated situations, you have choices as to what you can use. So why don't you try the next two, pause the video and then come back. We're going to put 2 more on this video, and then I'm going to do the rest of them on a different video. So looking at these 2, 8 to the x equals 32. The common base here is 2, okay? 8 and 32 are both powers of 2. 8 is 2 to the 3rd. 32 is 2 to the 5th. And then I'm going to bring down that x. So I'm going to write that in a different color just so we can kind of see that we were keeping that from the original problem. So from here, cross out the common bases. 3x equals 5. So x equals 5/3. Looking at the next one, 9 and 27, and this is why it's important to know those powers. You need to have an idea, 9 and 27 are both powers of 3. So 9 is equal to 3 squared. 27 is equal to 3 to the 3rd. And then we're going to bring down the next one, and something's going to happen a little different with this one. So because we have a binomial exponent here, I have to distribute and multiply both terms by the 2. So this ends up as 4x plus 2 equals 3. And then we are going to divide or subtract 2. 4x equals 1. So x equals 1/4. So in that first section, basically you should see mostly numbers you recognize. If one of the numbers, like in this top problem, the 5 is recognizable, just try to find a power of 5 that works for the other number if you don't recognize it as one of the ones that we memorized.